Hi, I'm Sean Gannon, and this is Minute Math, and we have another fun problem for you. We're given this picture. It's a rectangle, a 4x6, and we have an octagon inside of it. Don't judge my drawing here. And we want to find the side length of this octagon. A few things we know: the octagon all has the same side lengths for each length here. Again, let's not judge my octagon. I want you to pause this video and see if you can solve this problem, okay? If you don't want to pause it, well, just keep on watching. We're about to dive right into it. All right, so here we go. Going through how do we solve this problem. Let's go note some things that we know about this octagon. Well, the octagon has all side lengths here that are the same. Let's call it S, side length S. Now notice we have these right triangles going about, and these right triangles all have, well, the same side lengths, actually the legs of the triangle. Remember, we have right angles in the corners there. So let's call this length X right here, the short side, and the long side, let's call that to be a Y. Okay? And so now we have something interesting. We can make some equations from this. What do we know about our side lengths here? Well, an X plus an X plus an S has to equal the length of 4. So 2X plus an S equals a 4. Well, what about our Y's? Same thing that happens here. Y plus S equals a 6. So a 2Y plus an S is equal to 6. What else can we find out here? Well, using Pythagorean's theorem, we can say that x squared plus a y squared is equal to our s squared. Now, if we try to take our first equation here, we can get x by itself. In doing so, if we get x by itself, we get a 4 minus an s over 2. Now I'm going to do the same thing with the y. Put it down here, and y by itself is equal to a 6 minus an s over 2. Now with these two parts here, we're going to plug them back in for the corresponding x and y value in our third equation, and we'll have one equation that has, well, just the variable s in it. So we have a 4 minus an s over 2, let's go down here, all squared, plus a 6 minus an s over 2, all squared, is equal to an s squared. Now from here, I can multiply 4 to both sides of the equation and gets rid of that 2 squared in the denominator here, and we have a 4 minus an s all squared plus a 6 minus an s all squared is equal to 4s squared. So now let's go simplify this a little more. We have 4 minus s all squared. I think I kept messing up that minus sign. Don't forget it's 4 minus the s. And so that simplifies to be a 16 minus an 8s minus an s or plus an s squared. And the same thing here. 36 minus a 12s plus an s squared is equal to 4s squared. So now let's keep simplifying this. Let's bring all of our terms to the right hand side, so it's equal to 0. And we'll have 0 here, so I'm kind of doing that, bringing everything over. 0 is equal to a 2s squared plus a 20s minus a 52. And I did that simplification for you. Now from here, so I have a little more room, I'm going to write it up here, and I'm going to pull out a 2 from all parts here. I'm dividing both sides by 2, and I like actually flipping it around so I have the other parts first. So in doing that, I have an s squared plus a 10s minus a 26 equals a 0. So now using the quadratic formula here, I'm going to go get s by itself, and I just did the work for you here. S equals, I got a -5 plus or minus the square root of a 51. Well, we have two values for s here. Well, can they be negative? No, we can't really have a side length that is negative. S has to be bigger than 0. So s is equal to -5 plus the square root of 51 here. And so that comes out as a decimal, approximately a 2.1414 right there. And there we have it. Our side length for this octagon is that -5 plus the square root of 51. Well, one thing we know here when we're let's start over. Alright, so now using Pythagorean theorem, I'm just going to tell you what that's S is by, no, not Pythagorean theorem. Quadratic formula, Sean. Quadratic formula. I hope you learned something in this video, and if you did, please subscribe to this YouTube channel and like this video. This really helps us make more of these fun videos for you and for everyone else. So, as always, thanks for watching.